In this video, we will derive the sum and difference identities for sine. So by now, you know how this goes. We began from the fundamental identities, the Pythagorean identities, and then using those two identities, we prove this theorem, our sum and difference identities for cosine. And then using this, we came to the cofunction identities. Okay? So what we are going to do now is we will show and derive the sum and difference identities for sine. There is a rhyming into this. For cosine, maybe you can still recall your cosine alpha plus beta. It's cos, okay, minus sin. But for sine, for the sum and difference identities for sine, it's sin cosin. Show that sine of alpha minus beta is equal to this. Sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Okay, so we shall use this set of identities. Our sum and difference identities for cosine and your cofunction identities. And there is another set of identities which is going to be helpful. And in fact, I tend to ignore this when I was a student and even when I am teaching trigonometry. Our even and odd identities, cosine of negative beta is equal to cosine of beta, and sine of negative beta is equal to negative sine of beta. We kind of look at this as a very simple function, unassuming. It doesn't look like it's going to be a big identity. But after deriving three sets of identities, I came to discover that these two identities are in fact very useful. So how do we begin? Well, we shall begin by using our identities for cosine. The sum of angle identity for cosine. So cosine of alpha plus beta is equal to this. Now I want you to pay attention to alpha because I'm going to replace alpha by another angle which is pi over 2 minus alpha. Okay? So this is still a sum of angles, of two angles. Okay? Pi over 2 minus alpha, that's our first angle, plus beta. Okay, so this is what's going to happen. Applying now our sum identity for cosine. The cosine of this sum is equal to this. Okay, cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Now, this is where our cofunction identities will come in. Cosine of pi over 2 minus alpha is just equal to sine of alpha. Okay, so this one is just sine of alpha. And look at this. Sine of pi over 2 minus alpha is equal to cosine of alpha. So we are almost there. We are almost at our identity except this. The left side of our identity is far from becoming the sine function. Okay, so pay attention to this. Okay? So I'm going to group these two angles together. And you know what's going to happen with that operation? Okay? It's going to be subtraction. So if you want to verify if your factoring or your grouping is correct, all you have to do is just multiply -1 to alpha. So it's going to be minus alpha. And -1 times negative beta, it's going to be plus beta. Okay? So why did I do that? I did that because I want to show it in such a way that it will conform to our cofunction identities. This one, where is that? This one, okay? compare this with this identity. Okay? So this means this is just equal to sine of this angle, alpha minus beta. And so we are done with the first identity for your sine. So this is your difference identity for sine. So when we go to the sum of angle identity for sine, what we shall do is we will just replace beta by negative beta. And then we will apply our difference identity for sine. So sine of alpha plus beta is in fact just sine of alpha minus negative beta. And so we can now apply this. We can now apply this identity. Okay? This thing, which is equal to this, is equal to this. Sine of alpha, okay, times cosine of negative beta minus cosine of alpha times sine of negative beta. And so this is where the even and odd identities will come in. I spoke about this earlier. These identities, the even and odd identities, they don't seem like the big identities that's going to help you with your proving. And it turns out it is in fact very useful. Because cosine of negative beta is just cosine of beta. Sine of negative beta is negative sine of beta. But you know what's going to happen with this one, with this negative and this operation? It's negative, no, it's minus negative. So it's going to turn the operation into addition. So this is it. This is our sum of angles identity for sine. Sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So there you have it. Our sum and difference identities for the sine function. Now I'm going to show you the sum and difference identities for tangent. But I am not going to prove this anymore. It's going to be a challenge. I challenge you. I challenge you to prove these identities yourself. Okay?